this video, we're going to talk about simplest form and dividing radicals. So an expression containing a radical with index n is in simplest form when 1. No perfect nth powers as factors other than 1 are under the radical. So for example, the square root of 16 would not be simplified because I know that this is equal to 4 squared. That gets me 4. So I want to make sure I take out all of those perfect powers. So this, for instance, this one was the second power, that I take those out. Second, there's no fractions under the radical. And then thirdly, there's no radicals in the denominator. To meet the last two conditions, we must rationalize the denominator. And we did this by multiplying top and bottom of the fraction by an expression that eliminates the denominator. So for example, I have 5 over square root of 2. This is not simplified because there is a radical in the denominator. So to get rid of that radical, I would need to multiply top and bottom by the square root of 2. And that's because square root of 2 times square root of 2, that is equal to the square root of 2 squared, which just gets me 2. So this becomes 5 square root of 2 over 2. Okay, so let's look at some examples. So for this first one, I have the 5th root of 7 over the 5th root of 8. I want to get rid of that radical in the denominator in order to simplify this. So one way you can think about that is writing 8 as a power of a number. Well, I know that 8, I can rewrite that to be 2 cubed. And if you don't automatically see that, you can go ahead and use your factor tree. So this becomes 2 and 4, and 2 and 2. So 8 is equal to 2 multiplied by itself 3 times. And in order to get rid of that radical, I have to have a power of 5. This is a power of 3. So in order to get that power of 5, I can multiply top and bottom by 2 squared, or the 5th root of 2 squared. So when I do that, I get the 5th root of 7 times 2 squared, so 2 squared is 4, so I get 28, over the 5th root of 2 to the 5th. And now those cancel each other out. Because remember, the 5th root of 2 to the 5th is the same thing as 2 to the 5th raised to the 1/5 power. So when I do 5 times 1/5, I get 1, or 2 to the 1st power. And so that means that this is equivalent to the 5th root of 28 over 2. Okay, let's look at the next one. Next one, I have the 4th root of 3/4. So remember from our quotient property, this is the same thing as the 4th root of 3 over the 4th root of 4. Well, that 4th root of 4, I know 4 can be rewritten as 2 squared. So I have the 4th root of 3 over the 4th root of 2 squared. So in order to get rid of that radical below, I need 2 to be raised to the 4th power. So that means I need to multiply top and bottom by the 4th root of 2 squared. So that gets me 4th root of 3 times 2 squared over the 4th root of 2 to the 4th. And so simplifying that out, 3 times 2 squared, I get 12 over 2. Okay, now these next 4, I have some variables in there. So number 3, I have x over the cubed root of y to the 8th. So here I have a cube root. So I want this y to be raised to a power that is divisible by 3 in order to get rid of that radical. 8 isn't divisible by 3, but I know 9 is. So I can just multiply top and bottom by the cubed root of y. And when I do that, I get x times the cubed root of y over the cubed root of y to the 9th. And then the cubed root of y to the 9th is going to get me y third. So I get x cubed root of y over y third. And again, that's because there are 3 groups of 3 contained in y to the 9th. So one way that you can look at that is either writing out 9 y's and seeing that there's 1, 2, 3 groups of 3. Another way you can think about it is that you could rewrite that radical to be y to the 9th raised to the 1/3 power. And when you multiply 9 times 1/3, you get y cubed. So a couple different ways that you can think about that. Okay, so now this next one, I have the square root of 10x cubed over the square root of 5y. So here, whenever there's an index that's not shown, there's really a hidden 2 there. So this one, I'm looking for groups of 2. Right now on this radical, I only have 1 5 and 1 y. So I need 1 more. So that means I need to multiply top and bottom by the square root of 5y. So when I do that, square root of 5y times square root of 5y, I get 5y. And then on top, I get 10 times 5 is 50, x cubed y. But now I'm not quite done. I see in this top, I have some perfect squares that I can take away from that. And so I can break this apart into the square root of 50, the square root of x cubed, and the square root of y. So I know square root of y, I can't simplify that further. 50, I see that breaks apart to 2 and 25, and 5 and 5. So that means a 5 can come out there. So I have a 5 that's left, and the square root of 2 that's still inside. X cubed, I see there's 1 pair of x's that come out, and so that means I have 1 x here, and then there's just 1 x remaining, and then the y is still in there. And then lastly, to simplify this even further, I see I have a 5 on top and bottom of this fraction, so those cancel each other out, and I'm left with x times the square root of 2xy over y. Okay, let's look at 2 more. Number 5, I have the cubed root of 19a squared b over abc to the 4th. So there's a couple of different ways that you can do this. I would recommend going ahead and simplifying this fraction first, just to make our lives a little bit easier. And so I see I first have a squared on top and a on the bottom. And so using my quotient property, I see that that leaves just an a on top, so I have 19a. There's a b on top and b on bottom, so those just cancel each other out. And we had just 1 there, so that leaves just c to the 4th on the bottom. So I have the cubed root of 19a over c to the 4th. And then we learned from our quotient property that that is the same thing as the cubed root of 19a over the cubed root of c to the 4th. And now to get rid of that radical on the bottom, I need c to be raised to the power that is divisible by 3. 4 is indivisible by 3, but I see the next one would be 6 is. And so to get c to the 6th here, I need to multiply top and bottom by the cubed root of c squared. And so when I do that, I get the cubed root of 19a c squared over the cubed root of c to the 6th. And when I simplify that denominator, I get c squared. Okay, looking at one last one, I have 2 times the 4th root of 2xy over the 4th root of 8x squared y cubed. So first, looking to see if there's anything I can simplify. I see there isn't on either end. And so I'm looking to get this bottom to get rid of that fourth root. So I need everything to be raised to the fourth power. Remember, 8 is the same thing as 2 cubed. So to be raised to the fourth power, I just need one more 2. So I know I'm going to need to multiply a 2. For x squared to get x to the fourth, I need 2 more x's. And then for y cubed to become y to the fourth, I just need 1 more y. So I'm multiplying top and bottom by the fourth root of 2x squared y. So that leaves me at the top having 2 times 2, which is 4, x times x squared, which is x cubed, y times y, which is y squared, over fourth root of 2 to the fourth, x to the fourth, and y to the fourth. And so simplifying that, I have 2 times the fourth root of 4x cubed y squared over 2xy. And lastly, I see these 2's cancel each other out, and so I get the fourth root of 4x cubed y squared over xy.